welcome to the introduction of organic chemistry. This is your first chemistry topic in grade 12. Alright, now let's get to it. Now, organic chemistry is the chemistry of carbons. Alright, so this here is the chemistry of carbons. Alright, in this topic, the carbon atom is the most important atom. Out of all atoms, carbon is the most important atom. So I'm going to give you reasons why carbon is the most important atom in this topic. Alright, the first reason will be that the carbon is able to form 4 bonds. Alright, the carbon atom is able to form 4 bonds. Look at these bonds here. 1, 2, 3, 4. Right, so that is the first reason there. The first reason why the carbon atom is very important in this topic, it is because the carbon atom is able to form 4 bonds around it. Now, we can also look at the silicon, all right? So there is this atom here called silicon. It can also form a maximum of 4 bonds, but it is not stable. These bonds are not stable. So the carbon atom is the only one that is able to form 4 bonds and also become stable. But the silicon atom, it cannot do that. It doesn't have that quality of having stable bonds. All right, and the other importance of the carbon atom is that the carbon atom is able to form a longer chain of carbons. All right, this is what we call catenation. Can you see? It is very important to note down that a carbon atom is able to form or bond with other carbon atoms in order to form a long chain. All right, now that is what we call catenation. All right, but in the first importance of the carbon, the first point there, we said it can form a maximum of 4 bonds. Right, so we can write it in brackets there. It can form a maximum of 4 bonds. All right, so it can form 4 bonds. That's what is happening there. Can form 4 bonds. Right, but then we have said that the second importance of the carbon atom, we can see that it can form catenation. What we know of catenation. So this is catenation here. That is catenation. The idea of the carbon being able to form a longer chain or being able to bond with other carbon atoms to form a longer chain. That is catenation. So the carbon atom is also important in our bodies because when we look at the DNA structure in our bodies is made of the carbon atoms. So this can support the idea that the carbon atom is the most important atom, all right, in the world, because in our bodies, our DNA molecule contains the carbon. This is the chemistry of the carbon atom. This is the chemistry that deals with the organic molecules or the organic compounds. An organic molecule or an organic compound is the one which contains the carbon atom. Not all compounds that contain carbon are organic molecules. Not all of them. You must know that carbon monoxide, carbon dioxide, and the other carbonates, these are not organic compounds because they are considered as non-living. Okay, they are considered as non-living. And then the other trick that I can give you, can you see that in carbon monoxide and carbon dioxide, there is no presence of a hydrogen atom. So for a compound to be organic, we must have the presence of the hydrogen atom and the presence of a carbon atom. So here in carbon monoxide and carbon dioxide, we don't have hydrogen. We have only the carbon atom. So it means it is not what? It is not an organic compound. These are not organic compounds. So it's also very important to note it down that an organic molecule is a molecule that contains carbon atoms generally bonded to one other carbon atom as well as the hydrogen atoms, right? As well as hydrogen atoms. So we must have both the carbon and the hydrogen. So that compound will now become organic, right? So that's very important. If you take a look at your carbon monoxide, we know that it doesn't have hydrogen. Therefore, it's not organic. It's inorganic. How about carbon dioxide? Also doesn't have the hydrogen atom. So it is inorganic. It is not organic, but it is inorganic. Now, that's very important. If you do chemistry in university, you will discover that there is organic chemistry, there is inorganic chemistry, and then there is physical chemistry. Now, the organic chemistry is by far the biggest chemistry, all right? It is the biggest section on chemistry. That's very important to note down. All right, now we are going to be looking at the homologous series. We're now going to be looking at the homologous series. Now, the homologous series is dependent on the functional group. The functional group determines which homologous series we are dealing with. Now, what is the homologous series? I'm going to define it here. Homologous series is a group of organic compounds with the same general formula or the same functional groups. Those are the homologous series, all right? Group of compounds with the same general formula or the same functional group. That there is the homologous series, okay? Now, the best way to remember this is by saying these are the families, all right? These are the family of compounds. So these are families, all right? But never write this in the exam. Please, I'm begging you. So it effectively means that which family of compounds does this compound belong to? That's what it means, guys. All right. And the reason why we have homologous series is because of the functional group. So the functional groups helps us determine the homologous series, okay? The families. It helps us determine the families, the functional groups. So let's look at the functional group. A functional group can be an atom. It can be an atom. It can be a bond, or it can be a group of atoms, all right, that is responsible for the reactivity of an organic compound, all right? So the atom, the bond, the group of atoms, all right, these are the functional group, but then they are responsible for the reactivity of an organic compound. But remember that different compounds, they react differently according to their different electronegativity and some of the factors, all right? So atoms and compounds, they react differently. Some react faster, some react very slowly. So that is the functional group. The functional group, it can be an atom, it can be a bond or a group of atoms that is responsible for the reactivity of an organic compound. So that is very important. So I always think of it like a superpower. So a functional group can be seen as a superpower. It gives the compound its superpower. So don't write this in the exam again. What is it that makes this particular compound or molecule able to react? That is the superpower that we're talking about, which is the functional group, okay? So don't write superpowers in the exam. This is just for you to be able to memorize it quickly and easier. Now, before we go any further, I also need to teach you how to count in organic chemistry. That sounds weird, right? Because you know how to count. That sounds weird. You know how to count, right? But in organic chemistry, there is a way of counting. So let me teach you that. Now, we are going to be specifically counting at the number of carbons, all right? Now, let's look at the first carbon. If we are having 1 carbon, if we are having 2 carbon atoms, if we are now having 3 carbon atoms, all right, 4 carbon atoms, 5 carbon atoms, we are going to count from 1 up until 8, all right? In grade 12, you only count from 1 to 8. If we're having 6 carbon atoms, 7 carbon atoms, if you are having 8 carbon atoms. So if you're having 1 carbon atom, we're going to having meth. This is going to be meth. All right, if you're having the 2 carbon atoms, that is going to be eth. 3 carbon atoms, that's going to be prop. Prop means 3, all right? 4 will be but. 5 carbon atoms, that's going to be pent. 6 carbon atoms, that's going to be hex. 7 carbon atoms, that's going to be hept. 8 carbon atoms, that's going to be oct. Okay, and that's where we're going to end for grade 12s, all right? And if you want to continue to 9, that's going to be nano. These are the prefix. You know from English that a prefix, it is the first part of the word, right? That first part. So these are the prefix. Let's just make it plural. Prefixes. So these are the prefixes that we are having there, right? Now guys, this is organic chemistry in a nutshell, all right? In the second lesson, we're going to go in depth. We're going to be focusing on the homologous series. We have defined what homologous series are, but now we're going to be looking at the different kinds of the homologous series, the different groups. We're going to start off with the alkanes, the alkenes, the alkynes, up until the carboxylic acids. Okay, up until the carboxylic acids. So how many are they? They are 9. All right, 1 2 3 4 5 6 7 8 9. There are 9 homologous series. We're going to be looking at the general formula, the functional group, an example, the IUPAC name. This is just the naming, all right? And also later we're going to be looking at the intermolecular forces and the chemical reactions. Okay, so in the second lesson we are going to be focusing on the homologous series, the different type of homologous series, but we're going to start off with the alkanes followed by the alkenes. All right, that's going to be in the second lesson. And so thanks for watching. Please subscribe, like for more content. Right, this is going to be the most important content for the grade 12 learners. This is going to help you. All right, so thank you very much. God bless.